sometimes nature is the ultimate engineer.
Yeah.
Humans, we love to invent, we love to innovate and iterate, but sometimes we get stuck in linear thinking where come up with ideas, we get stuck on them, and they just don't work. But nature,
She knows, bruh.
nature has had billions of years to experiment and to change the design and to kill off some species that it just didn't like, and it had time to refine its solutions.
Got you.
And when us feeble engineers stop to look at how nature has solved a problem, sometimes we find a very elegant solution. And today, that is what we are going to be talking about. We are going to be talking about how nature just does it better.
Okay, got you. So this is the hack for engineers.
Yeah.
This is the hack of hacks.
Yeah, so when I started researching this... Oh, wait.
Taking
Before we
a
get
step
in there.
back. Okay, yeah, step back.
And I am joined by my co-host, Mr. Jonathan Delport.
That's me, that right here.
That's that guy. He's holding a green cup.
Yeah, green. I'm green cup. He's white cup.
I could give up chocolate, but I'm not a quitter.
Good man. How are you, Mr. Insula?
Oh, lekker, man.
Lekker, man.
Yeah.
Interesting episode.
I think so.
Okay.
Like some very cool stuff that came about.
Okay, got you, man. Well, let's not keep
And
them back.
So the global concept that we're looking for is it's called biomimicry.
Got you.
And that's when humans create solutions that are inspired by nature.
Makes sense.
So like for challenges in all fields, the living world has countless models that humans can learn from. And by taking inspiration from nature, engineers can sort of jumpstart the design process because we know that the solution has already stood the test of time. Now, there's a woman by the name of Janine N. Binyas. I think I said that right.
Okay.
And she's the one that coined the term biomimicry. She wrote a whole book about it. And she was basically like, why are we... Her whole, like one of her catchphrases is, every engineer should have a biologist at the table.
What? That seems absurd.
Yeah. So
Is that really what she said?
it's one of the things she said. Like, but her whole idea is like, obviously I'm glorifying it. But her whole idea is that nature has solutions and engineers are like
Too mechanical.
they're too technical, too mechanical, and they just don't know about all the stuff that nature does.
Got you.
So her whole thing is like, how do we bridge that gap? How can engineers approach these problems
And look to the natural world for inspiration.
From what she says is it's not just like an interesting design. It's also they can look at things like how do ants communicate about food? When food
got
is
you.
And
So it can be like a system level problem as well.
I mean, it's a very broad term in the sense that you could be looking at like forests, and we're talking about things. I can't remember
Like huge systems, basically.
how a tree will fall down, and then it will decompose, creating nutrients for the other trees.
But real question: if the tree falls down and no one's there to hear it, did the tree fall down?
This is not a philosophy podcast.
Okay, fair enough. So we need to have some biology friends. Anyone who's watching and who is a biologist, reach out to us. We'd be keen. We'd be keen.
So I thought I would tease 3 lekker examples of how real-life engineering problems were solved by looking at nature.
Okay, got you.
So I'm going to paint you a word picture. The year is 1898 in Japan.
Okay.
They have just released the bullet train called the Shinkansen bullet train. And it can reach speeds of up to 240 to 320 kilometers per hour.
It's a little bit, eh?
Now, I don't know if you remember what the speed of sound is.
300 meters a second, isn't it? Yeah.
Somewhere around that.
Somewhere there.
I don't know the exact number.
Got you.
Right? So when the engineers originally designed this bullet train, one thing they didn't really foresee was something called tunnel boring. So what happens is the train, really high speed, it goes into a tunnel and then it sort of acts like a piston. So in the front of the train, you get a really high pressure. You'll see there's a nice little diagram over there that sort of explains the whole thing. And so you get a really high pressure buildup in the front of the train.
Okay.
And as the train gets to the end of the tunnel, just as it leaves, it creates a sonic boom that can be heard for up to 400 meters away.
Sherbet, man. That's pretty hectic.
So
So it compresses the air so much that by the time you get to the expansion zone, it's ready to sonic boom.
So for the residences that lived where this tunnel exit is, huge problem.
Not great.
Not a good time.
Not good
happy.
for the taxpayer. No.
So engineers were tasked with finding a solution, and they were a little bit constrained. They didn't want to sacrifice speed,
Okay.
and they didn't want to use more energy.
Makes sense.
Okay,
I get that.
On that team, there was a man named Aiju Nakatsu, and he was the general manager of technical developments, or the technical development department. I don't know if that's the company or
Sounds
the
like a
government.
made up
But his
position.
whole
Yeah.
thing is he loved birds. He was an avid bird
A
watcher.
birder.
He was a bird watcher, and he did a few things. So one of the things he looked at was the wing design or the feather design in owls.
Owls?
And I know you're an owl man.
I love owls because you can't hear them fly.
Exactly.
They
So-
fly and they just go.
He applied
people
something
listening-
about the wings into the suspension,
Yeah.
and the suspension was quieter.
Got you.
Another thing he looked at was like the bodies of penguins,
As you do.
as how they're able to slide on the ice so efficiently
Makes
and
sense.
majestically.
Makes sense.
But that is not the most notable thing. The most notable thing is the kingfisher. It's a bird, if you didn't know
I like
that.
me a good kingfisher.
And-
yeah.
He noticed how the birds would dive into the water and not create a splash. And he thought to himself, hold up, I'm going to look at how these birds do this. So a lot of science and research went into it. And they basically redesigned the front of the train, the nose, to mimic that of the kingfisher.
That's pretty cool, man.
So,
I think my only advice to Mr. Mukatsu is Nakatsu. Just enjoy it, man. You don't have to go out there watching kingfishers and think I can solve your problems at work. Be in the nature.
I think he was in it. I think he was
He
already
was just
there.
inspired. Okay, got you. That's beautiful, man.
So here's where it all comes together.
Got you, yes.
Here is why we tip our hats off to Mother Nature.
To the kingfisher.
Not only did it solve this whole sonic boom problem, the train was now able to travel 10% faster
With the same energy.
with 15% less energy.
You're joking.
So it could go faster with less energy.
You're kidding me, bruh. No ways. Okay, that's pretty cool.
That's
Okay,
cool, eh?
I'll give it to the little kingfisher. Even when you put the pictures next to each other, it looks exactly the same, man.
Yeah.
I love it. So, Mr. Nakatsu,
Hats off to you.
hats off to you and the kingfisher.
So, Mr. Dartboard, am I convincing you that nature knows what it's doing?
I won't lie. When I saw this picture, I was convinced, man.
Convinced.
It looks exactly the same. It looks like the bird was designed after the train. That's how good it is. I know it's the other way around. Don't worry. I understand.
Okay,
that.
so the next thing we're going to look at, I'm gonna paint you another word picture.
Okay, I'm ready.
Okay.
Do it.
So 40% of US water use is tied up in manufacturing and power plants, most commonly.
40%. 40.
Yeah, 40%. That's
Okay.
about $30 billion of annual cost just for like cooling and water supplies for this.
Really? Yeti. Okay.
Yeah. So the thing is, so if you look at cooling water towers,
Yeah.
like at a power station, it's people think it's smoke. It's not smoke. It is water vapor being released into the air. So scientists were thinking, all right, how can we address this? Because there were a few other problems involved. So people didn't like the plumes,
How it looks, basically.
Yeah. There was like economics, because like now we're wasting billions on water supply.
Yeah.
Now it's environmental, because you where you getting that water from? Now
Yeah.
it's water
Yeah,
that's
yeah.
not being taken out. And there's also like a safety regulatory thing going on there. Like acid rain. That
Yeah,
kind
because
of
you're
stuff.
putting it into the atmosphere. Yeah, fair.
So scientists turned to the humble darkling beetle.
What?
It's there's a nice picture there.
Okay.
So
The darkling beetle.
So these beetles have special structures on their bodies.
Yeah.
Some of it's hydrophobic, some of it's hydrophilic.
What's the difference between those two?
So hydrophobic means it repels water, hydrophilic means it attracts water.
Okay, got you.
Now what this bad boy would do in the morning, he'll climb up on a dune, probably be like, just another Monday.
Yeah, got you.
A little bit parched in his little beetle throat.
As you do when you wake up.
Yeah. I mean, like most of the time when you wake up.
I need me a glass of water when I wake up.
He'll climb to the top of the thing. He'll lift his little bum in the air, and droplets will start to form on his back. Why? Because they're hydrophilic.
Nice.
Then there's sort of like a channel that goes to his mouth, and the water then flows.
So it's even automated.
He's automated.
What a G. That's pretty nice.
So
it basks in the fog, standing upside down on top of sand dunes. Its back is covered in bumps that have water-loving tips and water-repelling slopes. This structure encourages tiny droplets of fog to stick to the surface. As the droplets coalesce to form larger drops, gravity causes them to roll down its back and into its mouth.
So the solution is what scientists have done. They've created something called it's called a mesh or a fog net.
Got you. I've seen these things.
And it's as you think it is. It's a
big net
that you put up on when there's a nice foggy, and then the water will condense it. And then now through different engineering developments using different materials, like obviously we've increased the efficiency of how well the water can condense onto the net. And it's like this solution is really good for like coastal regions and like where there's high fog. And they even put like advanced coatings that can purify the water.
You see, look at that. Come on.
So they're trying to use things like building integrated design. So now it's part of a building, and then with a little capturing device.
That makes so much sense.
The possibilities are endless.
That makes so much sense. That's really cool.
So yeah, just to maybe kind of quantify. So a typical fog net can get about 3 to 5 liters of water per day per square meter.
Decent.
I've seen the numbers range depending on material, depending on design.
And where, obviously.
But typically 3 to 5 liters.
Yeah.
And there are scenarios where they've been higher on. So there's 2 regional examples. In Peru, it's like a coastal zone, they have a whole sort of like little setup there.
Yeah.
So you'll see there's that picture there. It looks like just a bunch of nets there. And on a good day, and we're talking a real good day, they were able to collect 400 liters.
Yes, dude.
So a day. But that's, again, like optimal conditions.
Is that 400 liters for this whole farm?
Yeah,
or
for
just
the whole farm.
Okay, got you. Cool, farm. Man, that's awesome.
And then in Morocco, in Mount, I'm gonna butcher this, Mount Bus Megiddo, they reported up to 6,300 liters.
6
I'm
tons
not gonna lie,
of
I don't know
water.
if I believe that figure.
Well,
when I opened the article, like it was a
clickbait article.
It wasn't in English. So
how's this? I want to believe it.
I also want to believe it.
Okay.
So I feel like that's a nice humble solution. Looking at the dung beetle.
It's so nice because it's so simple. No moving parts, no nothing.
Yeah, you just put up a net, it catches water, and now
does
you've
its
got
thing.
water.
Oh, I love it, man. All right, what's next on your interesting scientific examples?
So now, the final example. So again, let me paint you a picture. You've got solar panels.
Yeah, I love solar panels. Yes.
Yes.
I
know. I mean, you're a solar panel.
I'm a solar guy. Yeah.
But now, because your surface is too smooth, too shiny, you're reflecting half of the sun rays away.
Don't want that. I want all the sun rays.
So scientists were like, okay, well, wouldn't it be cool if we could prevent that?
That would be great.
So the moth has developed through evolution. If you look at a moth's eyes under a microscope, you'll notice it's not just like a smooth surface, right?
Okay.
It's got these little like sort of ridges.
Yeah.
And effectively what it's doing is it's gradually changing the refractive index, like as it goes down. So what this causes is less reflection.
Okay.
So they evolved this accommodation so that predators couldn't see them. So they could fly around safely.
Really? Gee whiz, okay.
And so I was like, let's look at that and see how can we apply the structure to different things. So they created something called roll-to-plate UV nano-imprint lithography. Say that 10 times.
Roll-to-plate, I'm going to try to remember, UV nano lithography.
Imprint lithography.
Okay, explain that for us, Mr.
So
Hussar.
again, the moths achieve this effect through the structure. Like, I know we all know about the butterfly wings.
Yes.
It's a very similar concept.
Got you.
So what scientists did is they created a mold that sort of mimics that, and then they bring in like a plastic sheet, probably like PDMS or something like that, and then they basically press it in, and then it makes that structure.
That's so cool, man. Honestly, and then you layer that over the solar panel.
Yeah, you layer that over the solar panel,
and it reduces.
Yeah, so there's another
reflection.
Picture over there, and that's the basic structure of it. So that's kind of what it looks like, and they did a few tests, and they said, okay, how long does it take to harden?
That is so cool, man.
Yeah. So now, through this whole process, now they optimized the whole thing, and when they did their tests, they found that they were getting less than 1% reflection, which is, according to this, much better than normal glass.
So we don't know what the normal reflection is on.
And even on like
glass.
A wide angle, so like if you're looking at directly or if you're going like at a wider angle, they were still getting reflection below 4%.
Nice.
So where this is applied is, like as I mentioned, it's solar panels, also like on your TV screens, so that like those anti-glare sheets
on your spectacles.
That's what this is. This is the technology.
This is that.
Yeah, this
like
is
that thing I buy for my TV. I mean my computer monitor. That little film. That type of stuff.
But wait, there's
more. Oh my goodness.
This structure is also self-cleaning.
Oh no, I don't believe that. Self-cleaning.
So like water and dust just rolls off of it. Like
that is. Nature truly did it better this time, man.
So this solution,
That's
it's cost effective, it's easy to scale, it improves solar cells, it improves screens, LEDs, all of those things, and it reduces maintenance.
That is so awesome.
So just a few takeaways, because that's I mean, like there's many examples.
Give it to me plainly.
I'd just give
it to me plainly. 3
of the coolest ones I found. So I think nature holds already made solutions. We just need to learn from nature.
True. Okay.
Biomimicry, you can think of it as like a fast trick, and for designs, and it's already stood the test of evolution.
Yeah.
So, and when we implement nature into our designs, it makes our tech faster, cleaner, and more efficient. So I would advise engineers to look at nature as 100%. A mentor, not just a resource.
No, 100% agree, man. I think so interesting. Like you say, nature's had billions of years to refine this stuff. Why take the long route when you can just look and apply? I love it. Great topic, Mr. Unselar. Really, really enjoyed it.
So that's pretty much it. Don't keep it nice, short, and sweet.
No, perfect. I loved it. I am titillated.
I'm glad.
Mr. Unselar, any recommendations this week?
I would say the old Disney movies, man.
Oh, is it?
Like,
okay.
I told you I watched Hercules.
Yeah. So good.
Yeah, good. It's just good writing.
I watched a short. I can't remember if it's in the series or in the movie. It's where Hercules gets to design his perfect woman. Was that in the movie?
I know that. If it was, they took it out.
Is it? Oh man,
maybe
was
it's censored. Who knows?
Maybe it's not PC. For me, I watched It's a Wonderful Life. Not for everyone. I'll be honest with you. It's long, dude. It's over 2 hours long, and it's old. You know how like old movies are slow? Like this was slow and long. But overall, I think a very good moral lesson for us to be content with our life.
What's the premise of the show?
So the whole thing is that this guy, he feels like he was meant for more. He was meant to travel the world and stuff, and he gets like caught in life, basically. Like he has to take over his dad's business. He has to do this. He has to do this. He has to look after his town. And his brother gets to go do all these amazing things and be the famous person and be the oak who did this and get the Purple Heart and all of that. And then basically like at the end of the film, he wants to like commit suicide because he's going bankrupt. And then an angel comes to him and says, this is what would happen if you never existed. And then it sort of wraps up there. But it was good, man. Lots of Coke and Pepsi. And for me, it's wild because like the wildest thing for me is how different the world was back then, because it was obviously made in the 40s, 50s. And like kids after school, it was normal for them. You have a job after school. Like his first job was to serve like sundaes and Pepsi to little kids at this guy's shop.
Nice.
Dude, the world is so different. It's actually wild. But anyway, yeah. Would recommend, but it's a long watch and it takes a bit of laboring. I'll be honest with you.
I would say for my parting words, Don't do drugs.
Don't do- That was nice. A little inside joke. Thank you guys so much for watching. If you want to reach out to us, it's highlevelpodcasts@gmail.com. Please hit that like button, that subscribe button, and we'll catch you guys in the next one.
And let us know your recommendations.
Let us know your recommendations in the comments below, or any cool biomimicry that you know of. We should probably do this during the podcast.
Yeah, we
Tell
should really
people
start
to,
in like
injecting in okay. But anyway, we love you guys. See you next week.